All right, welcome back. We're doing the back of your handout now for scientific notation. So the first video you watched of scientific notation was for large numbers. The second video you're watching for scientific notation is now for small numbers. So this is kind of when we have a negative exponent now, so like this. So for positive exponents, we were moving the decimal this way. So we were going, trying to find the camera, we were going this way. So we took the decimal from this big number and we said, okay, if I moved the decimal nine spots in the positive direction, so to the right, I will end up with this number. This is now telling me if I move this decimal 11 spots in the negative direction, so to the left, I'll end up with a really tiny number. Okay, so something that looks like this. So now, this is equal to a bunch of different things. This is equal to 0.0006 divided by 10. This is also equal to 0.006 divided by 100. This is also equal to 0.06 divided by 1,000. This is also equal to 6 divided by 100,000. Okay, I missed one in here. This is also equal to 0.6 divided by 10,000. Okay, so in other words, this is equal to 6 times 10 to the negative 5. And the reason it's times 10 to the negative 5 is because what is 10 to the negative 5? Well, if I go 10 to the power of negative 5, that means I'm taking the number 10, or we'll go right here. I'm taking the number 10, and as I know, for a whole number, the decimal is technically at the end because it's 10.000, right? And I'm now going to move my decimal 5 backwards, okay? So I'm going to go 1, 2, 3, 4, 5. So if I'm doing 6 times 10 to the negative 5, I'm going to take my number 6, and I know my decimal is here, and I'm going to move it back 5 times. I'm going to go 1, 2, 3, 4, 5. And it's there now, okay? And then all of these get a 0. So now I have decimal 0.00006, just like this, decimal 0.00006, okay? And I always write my 0 before the decimal as well. So even though there's not a thing here, there's not a spot there, I write 0 point and then all of those numbers. Okay, so here, by the same logic, this is equal to 0.01234 divided by 10. This is also equal to 0.1234 divided by 100, which is also equal to 1.234 divided by 1,000. Notice I'm moving the decimal once every time, and I'm adding a 0 to the number I'm dividing by every time. This is also equal to 1.234 times 10 to the negative 3. So what that means is if I take my number 1.234 and it's telling me I need to move my decimal backwards in the negative direction 3 times. 1, 2, 3. That's where my new decimal is. And I now have 0.001234. 0.001234. Just like this, 0.001234. Okay, but obviously that's very annoying to write out every single time, and so we don't write it out every single time. So here it now says, the diameter of a grain of sand is 0.0024 inches. And we need to express this in terms of scientific notation. So again, we want one number before the decimal, just like how we have here. It's a number, decimal, blah, blah, blah. Okay, so we want only one number before the decimal, which means we want our decimal to move right here after our first actual number that's not a 0. We want it to move once, twice, 3 times, okay? But instead of being here, it's in the more negative direction, right? This is a very small number. So I'm going to say that this equals 2.4, but it doesn't actually equal 2.4. 2.4 is what I have here. It actually equals 2.4, but then I have to move the decimal 1, 2, 3 times backwards. So I get times 10 to the negative 3. Okay, inches. Then I go here and it says the mass of a dust particle is this tiny, tiny, tiny number, kilograms. Okay, so I know right away that I need to have my decimal right here, and it needs to be 7.53. So it needs to be my first real actual number, my first integer. Okay, decimal, the things that are right after it. But I need to now say, okay, but how many times do I want the decimal to move this way in order to have this many zeros here? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times to get my decimal over there. So I'm going to say 7.53 times 10, and I moved it 10 times. My base is always going to be 10. It's the exponent that changes. Okay, and this is talking about kilograms. And this will actually be negative 10, sorry. So we moved in the negative direction. My exponent is negative. So now it says for you to try. Right away, I know I want my decimal to be there. And I know I'm going to want 9.81. So your actual numbers we want to write, but we want one of those actual numbers before the decimal. And I'm going to say, okay, how many times do I have to actually get it there? 1, 2, 3, 4. Then I'm going to go backwards 4, which means 10 to the negative 4. Okay? So then we go to question 2. They want us to now take it in scientific notation and put it into standard form. So here I have 1.2. But they want me to go backwards 7 times. 1, 2, 3, 4, 5, 6, 7. Right here. And in all of these spots, I'm going to have 1, 2, 3, 4, 5, 6 zeros. So my answer is actually going to be 0 point, and then 1, 2, 3, 4, 5, 6 zeros, 1, 2. Okay? Then I go to this one, and it's this equals, and they want me to move my decimal 13 times. So I'm going to go here, and I have 4.96. They want me to move my decimal 13 times. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm right here. So let's see how many zeros that is, how many bubbles I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 zeros. So this ends up being 0 point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 4, 9, 6. Okay? And now it says you try. So we have 8.5, and they want us to move the decimal 5 times in the negative direction. So once, twice, 3, 4, 5. So there's going to be 1, 2, 3, 4 zeros. Don't forget, you have to start it, though, as if there's a 0 before the decimal. So we're not just writing decimal 0.00085. It looks a little incomplete, so we're going to put a 0 before the decimal. So 0 point, my 4 zeros, 85. Okay. Now we go here. The SARS looks very familiar as a strand of COVID. The SARS-CoV-2 virus is 1.0 times 10 to the negative 4 millimeters wide. A red blood cell is 0.007 millimeters wide. Which one is smaller? And explain your reasoning. Okay. So let's look at them both in scientific notation, and then let's look at them both in standard notation. So we'll look at scientific notation first. And let's see what they look like. Well, one of them is already in scientific notation. Okay, so I have 1.0 times 10 to the negative 4. Well, what is the other one in scientific notation? I have 0.007. Well, scientific notation, I know I want 7 point something. So how do I get the decimal here? I have to move it 1, 2, 3. Okay, so in scientific notation, it would actually be 7.0 times 10 to the 1 to negative 3. Okay, so those are them both in scientific notation. Now let's look at them both in standard notation. Okay, we have them here. And so this one is not yet in standard notation. So we have 1.0 times 10 to the negative 4, which means we need to move our decimal 4 times backwards, once, twice, 3 times, 4 times. And there is going to be 1, 2, 3 zeros. Okay, so in standard notation, this is actually 0.0001. Okay, and in standard notation, the other one's already written in standard notation as 0.007. Well, which one is the smaller number? Okay, which one is the smaller number? Well, here, the more zeros we have, the smaller you actually are. So 0.01 is bigger than 0.000001. Okay, 0.000001 is actually very tiny. This one has more zeros. So I'm going to write out a little therefore statement and say, therefore, 1.0 times 10 to the negative 4 is smaller because it has a larger negative exponent. It has a larger negative exponent and more zeros in front of the number. Okay? And then lastly, we have these inequalities over here. And if you remember, inequalities are these arrows. And whichever way you think of it, you can either eat the bigger number like this, or you point at the smaller number. So it's asking us to arrange these from smallest to biggest. If I'm pointing at the smallest number, my smallest number goes here. This number needs to be bigger than this number. This number needs to be bigger than this number. And this number needs to be bigger than this number. Okay, so let's look at the ones with the biggest negative exponent. Well, we have, this one has a negative 3, negative 5, 2, and negative 1. Negative 5 is my biggest negative exponent, which means that's my teeniest number. So I'm going to go, okay, 4.3 times 10 to the negative 5. Okay, so I dealt with, not that one, this one. The next one that has the next biggest negative exponent is my negative 3 here, and I have 1.5 times 10 to the negative 3. Dealt with that one. This one is negative 1, so I have 1.1 times 10 to the negative 1. And then this one's a positive exponent, 2.8 times 10 to the positive 2. Okay, now if you wrote these out in standard notation, this one would be 1, 2, 3, 4, 5. I moved the decimal 5 times. There would be 1, 2, 3, 4 zeros. So in standard notation, this would be 0.000043.